Righto, there's a worked example here, which is forces resolution problem. This is a fairly straightforward one. Really, let's just have a look. Three forces of magnitudes 4 newtons, 6 newtons, and p newtons act at a point in their directions shown in the diagram. So there we go. We've got those three. They're all sort of pulling in different directions. The forces are in equilibrium, show that theta equals 41.4, correct to three significant figures. Now, usually on here, I would say draw a forces diagram, but there's really nothing else to add to this one, if I'm honest. So I think we can run with this diagram. So let's have a look. We've got two things to find out. P, that's part two. To find the value of p, and the angle theta. So thinking that if we're just looking in the horizontal direction, p doesn't come into it, but the only unknown in the horizontal direction is theta. So let's we'll do that first, because that's what we need to solve for. Theta. So let's have a look at the forces in the horizontal direction. So in the leftward direction, we've got four newtons acting. Well, it's 2 theta to the to the vertical. So if we were resolving vertically, it would be 4 times cosine 2 theta. But this other side, resolving horizontally, would be 4 sine 2 theta. And then if we resolve the 6 horizontally, then similarly we've got sine theta. 6 times sine theta takes us to this horizontal. So those two are in equilibrium. The whole thing's in equilibrium, so it's in equilibrium horizontally. So we've got this equation, 4 sine 2 theta equals 6 sine theta. Now we need a little bit of trigonometry here, and what we need to know is this identity that sine 2 theta equals 2 sine theta cos theta. Okay, so if you haven't done that in pure maths yet, and it's worth just kind of making a note of that and remembering that, because you don't need to do the whole trigonometry topic in order to be able to actually use that. So so there we go. So if we just evaluate that, 8 cos theta equals 6, cos theta equals 3/4, and therefore theta, if we look at the inverse of that function there, the inverse cosine, that's going to give us 41.423 significant figures. Right, so now we know the angle. That's good. Right, we want to find p, so we're going to have to look in the vertical. So if we resolve vertically, then p is going to be equal to, well, we've got this 4 newtons. That's an angle of 2 theta to the vertical. So that would be 4 times cos 2 theta. And then we've got the 6 newtons acting at an angle of theta, so that would be 6 cos theta if we resolve that vertically, and p is equal to the sum of both those two forces resolved vertically. So we know what theta is, so we can just plug those into that equation, and that's going to give us a value of p equals 5 newtons. That's 2 on decimal place. Okay, so that's fairly straightforward question, not untypical, and it's the sort of thing that you might well see. All right, so okay, I hope that's useful. See you in the next video.